Welcome to this video series on how to bridge assets from Ethereum to Binance blockchain. My name is Ayuba Ochanlugwa Muazu, and in this video session here, we are going to be creating an asset, deploy the asset on the Ethereum blockchain, and then at the end of the day, we will bridge that asset, that is transfer the asset from the Ethereum blockchain to the Binance smart chain. Now, what is the asset we're going to create? Just to show you the power of blockchain technology in agriculture, I chose creating a warehouse receipt asset smart contract. So the asset we're going to create is going to be a warehouse receipt where users deposit their crops into the warehouse, and then they get receipt for those crops that's deposited. So we're going to look at how this warehouse receipt financing that has been around for a very long time ago. We're going to see how blockchain can help in that area. So first of all, what is WHR? Warehouse, WHR means warehouse receipt. And back in the days, farmers used to, or they still do it up to today, they during the harvest season, when the harvest is plentiful, they have surplus of the grains or crops that they have farmed. So and the prices at that point will be very cheap, so consumers will buy the price at very cheap price. And after consuming those products, or even sometimes after wasting those agricultural products, the food becomes scarce, and people start looking for it. So the idea of warehouse receipts came into place, where people can warehouse their farm produce with a known warehouse, and then they get a receipt for it. Now, what we're going to create here is to see how we will record such receipts on the blockchain. So, WHR on the blockchain, it's a method we're going to use to save receipts, like I said, on the blockchain, so that those receipts are immutable, and then those receipts cannot be changed, especially the receipt number. So we're going to create a smart contract at the end of the day to be able to store this kind of receipt information on the blockchain. Now there are different methods we can do this, but for the purpose of this tutorial, we're going to create the receipt as an NFT, that is a non-fungible token, in which each receipt is unique. So each warehouse receipt is unique, and then it can be also exchanged for other goods or services. So that's what I'm going to take on this video tutorial. In session 1.1, we are going to start creating our WHR receipt smart contract. So thank you for watching. In session 1, which we will call this session 1.1, we are going to start creating our smart contracts for WHR, that's warehouse or receipts. So there are different ways we can actually create these smart contracts. So I'm just thinking we can create this as an NFT, or we can just store all the information on the blockchain. But then storing all the information about a receipt on the blockchain will be too expensive. So we're going to choose the option of creating the warehouse receipt as an NFT. And the receipt details, which includes like the receipt number, the farmer's name, the quantity of grains he has in the store, the price as of the time of storing the grains, and all that. We can store this information as a receipt on another decentralized technology called IPFS, which stands for Intraplanetary File Protocol. So we are going to store the details of our file, of our receipt rather, in IPFS. But then let's quickly go to Remix IDE, where we are going to create our smart contract to mint NFTs, and then store the details of the NFTs on IPFS. So let's just quickly create the smart contract. I'm gonna click on contract here. Make sure you go to your Remix IDE. I believe if you've watched a lot of my videos, you would have I've introduced the Remix IDE, and it's a great tool for writing smart contracts. So we'll just click on new file, and then let's just see warehouse receipt. So just name it WHR, yeah, .sol. So it stands for warehouse receipt. Now we're going to use Open Zeppelin, and then we're going to leverage on Open Zeppelin smart contracts to pick an NFT smart contract that we can modify a little. So let's just go to Open Zeppelin. So which is openzeppelin.com. So we just open that. Okay, I've also introduced Open Zeppelin to lots of my application, and why it's a standard library that you can use to quickly build and upscale your the app development. So we are going to the contracts, and then we want to go to docs. Yeah, I believe we want to go to docs. Good. So of course, you know, the another name for NFT is called ERC721. So we'll click on ERC721. And then we're just going to pick the default contracts that they have here. You can see I'm on this version 4.4.x version 4 as at the time of shooting this video. So there are different versions here. So probably you might have a higher version then. So you can just quickly so we're going to pick this game contract that Open Zeppelin has, and we're going to modify it to fit what we have. So I'm going to copy this completely, paste it on my Remix IDE. Since the aim of this tutorial is to show you how to um, bridge assets between from the Ethereum blockchain to the Binance blockchain. So we're just going to change this contract name to warehouse receipt. So we'll just say WHR. WHR. And then yeah, we need the token ID. So we can just change this to warehouse receipts. We name this WHR. We can change this to farmer. I can change this award item to, I'm going to explain this. Let me just change all this. You can just say mint receipt or create receipt or mint receipt. Mint receipt. Then so definitely we'll change this to farmer. Good. I think this editing that we did should be okay. Now, as we all know, an NFT smart contract has something that is very unique that differentiates it between or that differentiates it from the ERC20 smart contract, which is the token ID and then the token URI. Now, the token URI here points to an external URI that contains information about a receipt, and then the token ID is like the unique number for each NFT that is being minted. Let me see, why am I having this error? Okay, undeclared. Okay, I think it's compiled successfully. Okay, so as I was explaining, the token ID, it's uh, the unique, it defines, is the ID of each receipt or each NFT that is being minted. So in the case of this small smart contract here, what we're doing here is we mint receipt for each farmer that comes to deposit items in the warehouse. So if the farmer is depositing, the app, or rather our smart contract, will first of all get the farmer's address, and then the token URI, the details of um, the grains or the items the farmer is bringing to the warehouse. So instead of storing the details on the blockchain, we store these details on an external decentralized application like IPFS, and I'm going to introduce you to. And then each receipt, we create a receipt ID or token item ID or new item ID for each receipt to differentiate uh, that. So I can so that's that about the smart contract. Just these simple changes. And then now, before we're able to deploy a smart contract, let me quickly take you to IPFS. So let's check our IPFS website. I think it's ipfs.io. Good. So, and then let's look at it. Now, IPFS powers the distributed web. Like you can see here, it's a peer-to-peer hypermedia protocol designed to preserve and grow humanity's knowledge by making the web upgradable, resilient, and more. So basically, what IPFS does, it's more like the blockchain, a decentralized web where files. Okay, if you've used BitTorrent before, then probably you know what IPFS is. So, and but then the difference is IPFS aims to surpass HTTP in order to build a better way for all of us. So if you upload your file to IPFS, it's stored in different computers all around the world that connects to the IPFS network. So and then you can see the advantages and disadvantages here. Today's web is inefficient and expensive. Today's web can preserve humanity's history. HTTP download files from one server at a time, but peer-to-peer IPFS retrieves pieces from multiple nodes at once, enabling substantial bandwidth saving with up to 60% saving for video. IPFS makes it possible to efficiently distribute high volumes of data without duplication. So you can see this is very, 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 very important. And the average lifespan of a web page is 100 days before it's gone forever. The medium of our era shouldn't be this fragile. IPFS makes it simple to set up resilient networks for mirroring data, and thanks for content addressing, files stored using IPFS are automatically versioned. So this is about IPFS, and then you can get to read about it. Installing IPFS on your desktop is very easy, and they also have a browser extension which I've already added to my own browser, which is this IPFS companion here. If I click on that, so I already have this extension on my browser. Good, so that's IPFS companion. You can add this to your browser by clicking on this button here, and then you can add it to your Firefox, Chrome, or Brave browser. So that's that. You read about IPFS. It's a very a unique work thanks to the IPFS team enabling these projects to come true. So what we're going to do now is we're going to store our receipt information on the IPFS network. And the receipt information can just be anything. It can be a text file, it can be a PDF, it can be an image or anything. But I'm going to create a text file using Notepad to just carry out a receipt information about this. So okay, so that's that about IPFS. And then we are going to go to this site here, anacrypto.github.io, to be able to upload our um, to be able to upload our receipt here and then get the URL of the receipt so that we can be able to use that to view the external receipt information. So why we're doing this is to make the blockchain, saving data in the blockchain, less expensive, since we already have our smart contracts here. Okay, so that is that here, and then we can quickly create a receipt. Let me just type one receipt. So let's go to Notepad. Okay, so I open Notepad. So just a very small receipt information. I can say item name, rice quantity, one bag, maybe 50 kg, farmer, Ayuba, receipt number, 123000, and then warehouse number, maybe AZ000, and then all other information again, price, maybe 5,000 or $500. So just basic information. So let's say this is the details of the receipt. So I'm gonna save this as a text file somewhere. So I can just save it on my desktop, WHR sample. So I save it as a text file. I'll save this information. So I have this information saved now. Now let's assume this is the receipt that was generated for the farmer. Now we are going to upload the receipts to IPFS, get the token URL, get the URI, a unique code for that receipt in IPFS, and then we're going to add that as our token URI for this NFT for this farmer. So if we mint this receipt for this farmer, we're going to get, of course, the farmer's address where we're minting the receipts to. We get token ID, and then the token URI will be the unique URI for this receipt, so where we can view the receipt information. And this is the beauty of mixing IPFS with smart contracts. You get to have this flexibility and all that. So I'm gonna pause this video here. In the next session, we are going to deploy this to the Ethereum blockchain and then look at it. Then we see how we can bridge these assets, which is this receipt, from the Ethereum blockchain to the Binance smart chain. So thank you for watching. All right, welcome to session 2 on this video series on how to bridge assets from Ethereum to the Binance chain. My name is Ayuba Ojanugwa Muazu, and in the last video session, we created the WHR, that's the Warehouse Receipts NFT smart contract, and it's just a simple smart contract that we can use to print warehouse receipts as NFTs. And the idea is to be able to deploy these NFTs into the Ethereum blockchain and then bridge these onto the Binance smart chain. So in this session here, we're going to deploy this warehouse receipts onto the Ethereum blockchain. So first of all, make sure that you have metamask installed, and you log into your metamask, and then you can switch to the royally tests network. So I'm gonna open up that. So make sure you're on the royally testnet network, and then you have some testnet ether for these. So you can watch my other videos on how to get the testnet ether for the royally testnet network. But although you can deploy this also onto Robston or rinkeby, yeah, so you can do that. Now, in case you installed MetaMask newly and you didn't get to see the testnet network, probably you need to toggle this so you can see it says show or hide testnet network. So all right, so we have this here now, and the next thing is to deploy the smart contracts onto this testnet network so that we can have our WHR receipts, and then we can mint the tokens, mint the NFTs rather accordingly. So now everything is compiled successfully. Just go to the deployment tab here, and then you switch this to injected Web3. And then if you're doing this for the first time, this will pop up MetaMask and it will tell you to uh, connect to your Remix IDE. But as it stands, Remix IDE is already connected to my MetaMask. Okay, I think this is not responding. This is not responding, so probably have to refresh the Remix IDE. Okay, I probably have to refresh this. Okay, so let's go back to the contracts. We're talking about warehouse receipts.sol contracts, and then let's go to our deployment tab. Let's switch this to injected Web3. This is a bit slow, it's not responding, so I just have to wait a little. Okay. I guess it's still compiling, so taking quite some time. Let's set this on auto compile. So this is just trying to load things up, so it's taking quite some time. Once compilation is done, okay, so it's compiled successfully. Let's go here. We switch to injected Web3, so you can see the Goerli network is displaying here. Now, you come to contracts here because we've inherited a lot of contracts. We need to switch back to WHR.SOL, which is the contract we're using. But you can see, because of these import statements here on OpenZeppelin, we did inherited a whole lot of contracts before we're able to get to this point of WHR.SOL. So, minting these NFTs or minting these receipts, a whole lot of smart contracts has been inherited. So now we click on the deploy tab, the deploy button rather, and this will pop up metamask on the Goerli testnet network. Just wait for these to metamask to respond, and we'll deploy these smart contracts. It seems to be unresponsive. Okay, good. So contract deployment, you can see the estimated gas fee and all that. So you can just click to deploy this contract. So the contract is deployed. We wait for confirmation so that we can get our contract address. Okay, good. I'm already seeing the information here, and then we can now scroll down here on the Remix IDE. Here is the contract address. And here are the functions of the contract. But then we can open these to view the contract address in the Goerli testnet network. So we'll click on that. Good. So here's a contract deployment. Now we can view these on the Block Explorer. So you see, it takes us to goerli.etherscan.io. And we can see the detail of our contract here. Good. So contract successfully deployed, and then we can see here's the contract address and other detail that you can see. Okay, so we have these now. We'll go back to our mix. Now, what we need to do now is to mint a receipt for each particular farmer. So let's say I want to mint a receipt to a farmer now. We have it here. So we'll mint a receipt by putting the farmer's address and then the token URI. Now, the token URI, just like I explained, is the receipt we are going to upload to IPFS, and which will have the different details of the receipt. If you remember, we created a receipt in the last video, which we stored here on the created this receipt we call the WHR sample. So we're going to upload this receipt. I can open this quickly. So we're going to upload this receipt to IPFS and then set the token URI to our smart contract to save us. Set the token URI in our smart contract. So go to this URL and crypto.getup.io. Just copy this or just type this on your browser and then to pop up this page. Now here we can quickly upload documents, images and all that into IPFS very easy. So just make sure it's on HTTPS and the node is online, and then you just choose a file. So just click on this choose a file. Of course, I choose the receipt, which is WHR sample, and then I upload this file. So you can see it's a plain text. So I just upload this to IPFS. The last video I explained everything all about IPFS. Now good, so what you just need to do now is so you can see the receipt hash has been created. So it is this. Good. So to view this receipt, we go to I think IPFS. Good, IPFS.infra.io. Then IPFS. I did this before. IPFS, and then you paste your hash that you created. So this is the hash of what I just created. So once you click on that, you can view the receipt. Anybody can view the receipt. So you can go to this URL that I created and you can see the receipt. Now good, so this is my receipt here. So we'll go back to our Remix IDE, and then for token URI I can just quickly put that. So it's on IPFS.infra.io /IPFS. Good, and that's now the farmer's address. You can use any address for the farmer. So let's say this is the address of the farmer. So I'll just copy the address in his account. Put that here. Good. So now I can now mint receipt now. Click on that. And this will pop up metamask, minting a new receipt. So just wait for metamask to come up properly. So I just click on confirm. Good, so wait for the receipt to be minted. We'll just get to see the message on watch the transaction. So you can see we have it here, contract interaction. Also view that on Block Explorer. Good, so that is successful, and you can see details of this. So the token ID now is 1, and it's warehouse receipt, and this is the symbol WHR. Now, if you go back to your Remix IDE, you can view the details of what you just created. For example, now we want to see the balance of the address. Here's the address. See that one NFT has been minted, so you can see. So that address owns one receipt, and of course, here's the name of this the NFT, and then here's a symbol WHR, and then the next thing is now if we say token ID 1, that's this should serve as the receipt number, or the token ID rather. Yeah. So it belongs to this address, and then if we want to see the token URI, that's where the details of the receipt is stored. It's stored here, so ipfs.io/ipfs and all that. So you can copy this, which I did, and then you view the details of your receipt like this. So this will be this is stored here permanently, and viewers can get to see this. So now we're able to deploy our smart contracts and upload the receipt. So the next thing for us is to display this on metamask, and then set up the BSC network and all that. Well, I'm gonna do that in the next video, so thank you for watching. Hi, welcome to session 3 on this video series on how to bridge assets from Ethereum to Binance by using metamask. My name is Ayuba Ochandugwamu, and in the last video we were able to compile and deploy our warehouse receipt smart contract onto the Ethereum blockchain. Now in this video here we are going to set up the Binance chain network, and then we are going to transfer the warehouse receipt from the Ethereum network to the Binance network. And then of course we also want to display the warehouse receipts that we've created on metamask. So the first thing we need to do is to be able to display the warehouse receipt we created as an asset onto metamask. So if you go to docs.binance.org, okay, this is for us, this is for setting up the network. I'll come back here, but you just have to check this. We have deployed our smart contract, right, and we have minted a warehouse receipt token. So now we need to display these on metamask. So you just click on metamask, make sure you're on the Goerli testnet network and having some Goerli testnet ETH on it. So you open up metamask, which is what I'm doing currently. Good. So I'm on Gorilla testnet network. Now I go to assets, and then okay, before I do that, I click on the address, the smart contract address we created. So I click on that. I'm going to add these on metamask. So now if you scroll down a little, you can see import tokens. So I click on that. I paste my contract address here, and good. So that shows me the symbol, which is a WHR, the warehouse receipt. Now we have no token decimal for this, so we can just leave that as 0. And then we add custom tokens. So you can see one WHR has been minted to this address. So we import this token. Good. So this account now has a WHR receipt, which they can view the receipt details. So if we scroll down, good. So if you click on this, we can should be able to view the details of this receipt. So view asset on Etherscan for this account. Good. So you can see why this is losing up. You can see the maximum total supply is 0 WHRY because we are able to mint receipts accordingly. So we have no maximum total supply for this NFT. We can mint as many receipts as we can. So and of course here's the balance for this address, which is a 1 WHR receipts. Okay, good. So now the next thing for us is to set up the Binance chain network onto metamask, and then transfer this receipt from this Ethereum network to the Binance network. And if you go to the Binance documents, that is if you go to docs.binance.org smart chain wallet metamask, if you scroll down, you'll see what I'm just really interested in is the chain ID, just to show you that. So just scroll down a little. You can read through all this. Shows you how to set up metamask and everything good. So here is what I'm interested in, the chain ID and the symbol and all that. So now the chain ID is 97 or 0 by 0x61. So that's for the testnet, and here's for the mainnet. Now, actually bridging these tokens would be easy using the mainnet, but I'm just gonna because there are no sites where we can easily bridge this token using the testnet, so I'm just going to like explain it to you. Now, we set up the network by going to this, then you go to settings. It's my correct, good. So you go to networks, and then you go to add network. So this will open up metamask extension, your browser tab. Good. So the network name we can say is test b. We can just say Binance test. Binance test. So, and the new RPC URL, okay, the chain here will say it is 97. The new RPC URL is we get the RPC URL, is it's here. Okay, BSC data seed, it's actually an image here. I'm not saying it. Okay, let me open this link on a new tab. Probably I see the RPC URL there, so we can copy it. Good, so this is the RPC URL for the mainnets. We are looking for RPC URL for the testnets, right? So this is the RPC URL for the testnets. So just copy any of this, and we add it here. And the currency symbol is actually BNB, and the Explorer is this. So for the testnet. So we save this network. And good. So we have a Binance testnet network stored on metamask, and you can see we'll have 0 BNB. So now for you to be able to transfer assets from the Binance network, you will need the faucets, the Binance faucet ether, and you can easily get that by coming here, docs.binance.org, and we look at the site to get the testnet ether. Oh, I guess there is a problem currently. So in terms of shooting this video, I think Binance it's having some issues. CEO, and there's plenty a lot of news out there regarding Binance. So okay, anyway, at this point we can get the testnet ether because of site is temporarily unavailable. Okay, so once you get the testnet ether, you can add that here, and then the next thing now is to bridge. Now there are two bridges that are available. We have the seller C bridge and then the AnySwap. These are two bridges that you can use, but the thing is these bridges are actually uh, bridging through the mainnet network, and we can do that now because that will cost us some ETH, and we don't have ETH on our metamask currently. So but I'm just going to show you, demonstrate to you how that is done. So we go to bsc.anyswap.exchange or seller bridge, anyone you choose, by going to binance.org en bridge. It will show you this, and then it's just very easy to bridge these tokens. So I'm just going to show you that. Good, so you can see now the first thing to do is to connect to our wallet, which of course is Ethereum or metamask rather, and you can read everything about the BSC AnySwap bridge here. So first of all, we connect to our wallet. Good, so we want to connect using metamask because that's what we have, and this will pop up metamask.
Okay, I'll just wait a little for metamask to connect to this. Okay, this is taking some time. Let's just wait a little. So let's just wait. Yeah, I wonder why this is unresponsive. Okay, I probably have to exit this page and reconnect again. Okay, it's saying that metamask has crashed, so I just have to do this again. So we click to connect to wallets. Guess there are some issues with Binance at this point. Okay, metamask has crashed on my PC. Okay, so let's reload this. Well, I'm just trying to reload metamask, and we can just connect to it because metamask has crashed. Okay, good. So we're connected back. Now let's try to connect to the wallet. Click on that, and you click on metamask. Well, I guess there are some issues probably with Binance today as of the time of shooting this video. So probably that's why I'm facing all these issues. Well, anyway, once you connect the site, the AnySwap.exchange to MetaMask, you will see the list of your coins here. You go to Bridge rather, this tab here, and this is just the same interface with this. And you see the list of your coins. You can select the network and then where you're transferring to. So in our case, it's going to be from the Goerli testnet network to PSC testnet network, and you wait for some few minutes for your tokens to be swapped or bridged from the Ethereum network to the Binance network. So that is that about this tutorial, and if you have any questions, you can please reach out to me and I can help you solve them. So thank you for watching.